So the client now knows that it needs to write to machines A, B, and C, and machine B is the primary copy. So what does the client do now? The client now sends this block X, to these three machines, to all three of them, telling them to keep it for now, not write it to their hard drive yet, and then eventually they'll write it together. So for now, the client sends this block of data to each of these machines. Okay, so step 1, send block to each machine. So at this point, at the end of step 1, all the replicas will have the copies of the data, but they haven't committed it yet to their hard drive. So they just have the data, they're holding it, waiting for the signal to commit it at the same time. So once the client gets an acknowledgement from all three replicas that they have the data, it then sends a commit message. And the commit message is sent to the primary. Remember, B was the primary here, the primary copy. And so the client sends a request to B saying, please commit this data. And the client also sends B the name of the replicas, right? So the secondary replicas A and C. So B first commits the data to its own hard drive. Then it sends a message to A and C asking them to commit the data themselves. So A and C both commit the data to their own hard drive. A and C respond saying, hey, we've committed the data. And once both A and C respond with success, B returns back to client saying the write was successful. Only when all three writes are successful does B reply with a success message. And at that point, the write is done. If any one of these fails, so let's say the write to C fails, B replies with a failure message. After that, you either retry or you fix C or do some other measure. So a question that might naturally arise here is, why did we first send all the data to these three and then do this two-step thing where we committed all the data in the second step? Well, the reason is that because GFS is meant for large files, this data can be large. And so you want to move this around efficiently. So by doing this, the client can smartly select, hey, A is the closest to me, so I'll first send the data to A. And then it can tell A that, look, B is closer to you, so why don't you forward this data to B? And then tell B that, look, C is close to you, so why don't you forward this data to C? So you can customize the flow of data. If you didn't have this, then everything would go through B. So B would have to forward the data to A and C, and so you would have no control over how the data flows. So by separating the data and the control flow, this is the data flow, this is the control flow, you've added some efficiency to the system. Okay, so what you'll see here was synchronous replication, right? Everything was committed at once, and if even one of the commits failed, the write did not succeed. And so this was an example of synchronous replication used in the real world.